Now in the first video, we really did send the right message. When someone says vector field, we just want to think of a whole plane full of arrows or a whole room full of arrows, but there is notation involved, and there's some basic stuff about drawing some real basic ones that we're just going to take a couple minutes and do. When someone says I have a vector field, they're going to use an arrow over an F. If this is a function of two variables, they're just going to put x, y in there. If there's three, it's going to be 3. There's always some sort of formula next to I. You can have x's and y's. There's always some sort of formula next to j. You can have x's and y's. You can see that the formula next to I we always call f1. The formula that's next to j we always call f2. Some nice examples would be something like, for example, x squared plus y squared I plus, say, 2xy times j. That's certainly a vector field. We have seen some other examples, for example, of something like 2x plus 3y I plus 4x minus 5y j. Now that's a linear transformation. We've seen those before. We should be okay with graphing a linear transformation little bit by little bit. There are some nice ones that people like to draw a lot, and let's just look at those. One that shows up a lot many times because of physics is xi plus yj. If you actually just start graphing those points, of course it's 0 at 0, right? But if you go to 1, 0, you have an arrow that points out, that points out, that points out, that points out, and you can see that the input vector in each case is exactly the same as the output vector. So this one's going to go like this, this one's going to go out like this one's going to go out like this one's going to go out like this. You can see that everything's radiating out, and for example, the notation they're going to be using for that specific one is going to be R. Now if this said xi plus yj plus zk, they would also use R because it's actually just radiating out. One more where we just try to draw something that only has one variable in it. How about something like xi plus xj? And we'll just try to plot a couple points and see what happens. When we put in 0, you get 0. When you plug in the point 1, 0, right? When you plug in the point 1, 0, you get the vector 1, 1, like that. When you plug in the vector 2, 0, you get the vector 2, 2. When you plug in the vector 0, 0, yeah, you get that. If I plug in 0, 1, I still get the 0 vector, right? If I plug in the vector 0, 2, I get the 0 vector all along here. If I try to plug in something like negative 1, 0, it's going to give negative 1, negative 1. That one's going to go like this. This one's going to go like this. This one's going to go like this. So we're going to get motion that looks sort of weird over here because over here it's all going up to the right. Over here it's all going back to the left. This isn't hard. We plot 10 points. We can see what's going on without killing ourselves. You can see, by the way, from the picture that if you draw it right, you can see there's no dependency on y. If you move straight up, you're actually getting exactly the same arrows that you were before. So we can generally look at the graph of a vector field and know whether x is involved or y is involved, just by moving a little bit to the right and a little bit to the left and seeing what's going on and seeing if anything changes.